Hi, my name is Andreas, and in this video I will show you how to start creating a small game from scratch in Unreal Engine 5. We will use some of the latest features but also established workflows from previous versions. We will build a small top-down game and import static meshes, textures, building materials, importing skeletal meshes and animations, and build a small interactive system and do a little bit of polish at the end. So let's start by creating a new project. When you open Unreal Engine 5, it presents you with the new templates you can start with. So they contain new mannequin, Manny, and Quinn. But in our case, we will start with a blank project and just call that first game. Everything we are building here, I do in real time. And when I speed up time, I will tell you. Sure, it's recorded in pieces to create a better flow so you can follow. I'm using the assets from a StackoBot sample project you can download from the marketplace. So here we are, and when you have the project open the first time, you can see this new map here, which is already set to word partition and has a pretty nice real-time lighting setup. But in our case, let's start a new map, and we don't use the existing ones, but we just do a completely empty level. Before we start, let's go through the new UI. Here's a viewport with our scene, and here's the outliner listing all things of our scene. Below are the details of what we have selected. Up here are different modes like select, landscape, and foliage that we can use later. This is the create menu with all kinds of actors we can place, and the green button starts your game. The view modes and show flags allow us to investigate our scene. Down here is a content drawer with a folder structure of our game that you can also open up with Control Space in all editors. With F10 you can toggle the sidebar. Let's bring in our first actor. We could navigate through the menu or just start typing. Let's select the simple sphere. Here it is, even if we can't see it. It's in the outliner, and also in the details panel you see the properties. When we switch the view mode to unlit, we can see it there. So let's make some light. We will use the environmental light mixer to fastly set up some lights. By creating directional light, you can now begin to see the sphere. We can directly change the values like the intensity, and with Ctrl L, we can change the angle of our light so it comes a little bit from the front. This is real-time lighting by default. In the project settings, under rendering, you can find the settings. New projects use the new global illumination system, Lumen. So let's add some more. An atmospheric skylight, a sky and atmosphere, the new volumetric clouds, and a height fog. We also want our atmosphere light fully real-time, so we check real-time capture in the skylight. The actors got all spawned at 000 in the world and are a bit hidden. So let's line them up a bit so we have a cleaner scene and don't lose the overview. What we also can do is creating folders in the outliner and move our actors for the light setup in there. Projects can very fast get very messy, and some housekeeping from the start can go a long way. Next, let's save our map. Again, let's keep it clean, so we want to do a new folder calling it maps and save our map as valley. When we now take a look in the content drawer, you find this folder structure. Now we want to bring in our first own asset. In the content drawer, we will create a new folder and call it props. That will contain our meshes, materials, and textures. Pressing import, let me choose an asset I want to bring into the engine. SMCreate is an FBX that was created in Blender, but you can use any DCC tool or get them online like from Sketchfab. We don't change any defaults, and we want to create the materials. After pressing import, our static mesh got added, as well as the 3 materials this FBX uses. With double click, we open this mesh in an own editor. Let's dock it up here. On the upper left, you find some numbers about the mesh, and the details contain 3 material slots. This button leads to the location of the asset. Let's open the material editor. On the upper left is a preview. Below are details. Most space takes a material graph where we find this big output node where we can connect nodes to. For example, this one is color we can change. When we hit apply, we can see the result on our mesh. We can zoom in a bit to see how the material is looking from different angles. Let's go back and improve this a bit. When holding 1 and doing a left click, you can create a node with 1 value. We can connect this to roughness of the material, and the preview is immediately updated. Hit apply again to see how this glossiness looks on the grade. Let's make it more interesting by importing textures. So we can import 2 textures here, grayscale grunge texture and a normal. So once this is imported, we will find it in the content drawer and can drag in the normal and connect that to the output pin. So when we zoom in a bit, we see these nice little bumps here on this material, which we can also witness on the crate if we want. So let's go back and do one last touch until this plastic is done. Let's bring in the crunch texture, and instead of using a fixed value, we use this for the roughness, which gives us this look that it's a little bit touched, which is quite nice. So here we go. This is our plastic material. So let's go to the next one. So next up is metal. Let's open up this material, and the first thing we want to do is changing the color a little bit. So let's double click here and make that a little bit lighter. Next, we hold 1 again and left click to create a scalar and put that into metallic and change that to 1. Now we have a metal ball. So we do this again now with 0 for the roughness, so we have this really shiny thing. Let's take a look how that looks like on the crate. That's nice. So again, let's make this a little bit more interesting by including some textures we prepared. So we go here and we have a normal again and a roughness. But we will do something slightly different. This time again, we drop in the normal and connect that to the normal output. But if we take a look at that ball, it's a little bit too noisy for our taste here. So we do a right click and then we look for something called texture coordinates, which gives us access to the UV tiling. So when we connect that to the UVs and then changing the values to, for example, 5 and 5, we will get something that's more desirable. That's nice. So let's take a look how that looks on our crate. That's cool. So let's go to the roughness again. And this time we will bring in the texture we prepared, but instead of using the RGB channel, we only use the red channel. So you can store different information on different channels in a texture. So, and this is our end result. Nice. In the middle, we want to do something like carbon, but a simple setup. Before we do, I want to show you something on the mesh. Here you can check the vertex color of your mesh. We painted some gray values onto the mesh, which we can now use in the material. Let's open up the last material. And again, we start with importing 2 textures. And again, one is a normal and one is this time one we use for the base color. Let's take a look on the normal for a second, which opens a new editor. Unreal identifies this as normal automatically and sets up the values it's needing. So we have nothing to do here, which is nice. Let's go back to the material and now drag both of those in. First, we add the normal. Again, not the tiling we want. So with the texture coordinate node and some very high numbers this time, we will get much closer to what we are looking for. Now let's use the grayscale texture for the base color. When we directly plug this in, we can see that we have the same tiling issue as for the normal map. So let's just connect our texture coordinate as well with the UVs for these grayscale texture. Nice. When we now hit apply and go to our crate, we can see that this fits very well. Now let's use this vertex color I've shown before. We do a right click and search for vertex color to get that input node. When we multiply this now with our texture output and connect that to the base color, we will now hit apply and go to the crate and see our result. So here's our final crate with the 3 materials we made very quickly. Let's bring in the floor by doing a right click on the sphere, go to replace actor and select the cube. Up here we go to the scaling tool and then we scale it down on that. We scale it up on X and Y. Now we have a floor we can use. We bring up the content drawer and drag in the crate we just made. We can move it around and rotate it to see it in our light setup, and we can move the camera a little bit around. We can also change the light again to test how our material reacts to the different light scenarios. And here we are with our first scene done. So now let's talk about logic. When we press play, it seems nothing is really happening. With a crate selected, we can scroll down in the details and select Simulate Physics. When we now hit play, this crate falls to the ground. The disadvantage is that this is only turned on this specific actor in the scene. If we bring in another crate that looks for the player exactly the same, it will behave differently. Because for this second crate, it's not set to simulate physics by default. This is where blueprints can come in. Let's create a new folder and call that Game Elements. When opening up the folder, we can do a right click to create assets. We will find a lot of different things, but we will concentrate on blueprints for now. And blueprints can be a lot of different classes, but we start with an actor. And we call that BP_crate. When we open this up, you can see the viewport here in the middle. On the right, we have the details for the components that's selected, and the upper left, we have the list of components, and below we have graphs, functions, and variables. Up here, you find the event graph for the game logic, but we ignore that for now. Let's add a static mesh component, which we call create mesh. We still don't see something because we have to set our static mesh crate in the details panel of our added component. So here we have it. The details of this component are identical to the one we saw in our level, including the Simulate Physics checkbox. We can also tweak it a bit by setting the mass and increasing a bit the linear and angular damping to introduce some drag to this actor. So we save this now and go back to our level. When we now bring in our blueprint we just made, also rotate it a bit and press play, you can maybe see it behaves a bit differently. The advantage is when we bring in another blueprint crate, it has the same default values we just introduced. And when we change it in the blueprint, all actors in the scene will change too. Now let's replace our floor with a landscape. We can delete our floor and select the landscape mode. This lets me create a landscape. We do not bother with the details yet and just hit create. Now we have a landscape that we can sculpt, paint, or use landmass tools, but I don't want to cover that. We can change the brush size. For example, the strength, and the brush size, and the fall off for smoother or sharper edges. I'm not a very good level designer, so let's try briefly to sculpt something that looks like a small valley. Like that. I'm changing a little bit the brush size and then just really fastly drawing something here. When you hold shift, we can also lower an area, like for example here. And then we can use this tool to smooth out some of the roughness we brought in. But yeah, let's keep it like that for a second and head over making a material for our new landscape. Back in select mode, we can select our newly made landscape. And in the details, we will find the landscape material. So let's make a new material for that. We create a folder named landscape and create a material here, which we name m_landscape. First, we don't want to have any glossiness on our landscape. So we can search for fully rough in the material settings and it does exactly what it says. So now we have a rough thing. So next we want to add the landscape layer blend node. We can add two layers. One we will call sand, and the other we will call grass. And when we plug this in now into the base color and we hold 3 and do a left click, we can create a vector node where we can set the color into like a darkish yellow tone. We do it again, but this time with a dark green. And now we hook this up with the two layers. Back in our level, we can add it to the landscape. So you can see it's completely black. Let's fix that by going back into the landscape mode, and in the paint tab, we can find our two layers we just made. But the information needs to be stored somewhere, so we need to create a weight blended info layer. And we do that for the sand in our landscape folder and the same for our grass. So with this done, we can select those layers and begin to paint here. Again, a reminder that this part isn't really my strength, but I will try my best to paint in some grass. You can use the same brush settings as for the sculpting. I think this is enough and that works for us now. we can hide my simple drawings with some improvements on the material. So let's import some more textures. Here I have two tileable textures, one for sand and one grayscale one for grass. So we can remove the sand color node for now, but I will keep the green. We can connect the sand and bring in this grass. And when we hit apply and check out the level, we can see that we have sand here and this very beautiful grass. But the tiling isn't very nice. So let's get back to the material and fix that. This time we will use an absolute vert position node, which gives us X, Y, and Z on a given location. As we do not need Z, we will use a component mask to get only 2 coordinates and not 3. R is X and G is Y in this case. Now we can divide that by a number to control the tiling. For example, 256 could work. And now we plug that into the UVs. And now when I move around, you can see this is vert aligned. Even in the editor, I really actually like that a lot. So let's copy this part and do the same for the grass. I'm copying it because maybe we want different values for now. So here, let's try like 512. So when we hit apply and go back to our level, then we can see the result. So let's get rid of this, go to manage for now, so we don't have the brush. And here we are. So here's our textures and the tiling is not too bad, but the grass is not what we want. So let's go back here and switch that back to 256 for now. And now some cleanup. So there's a very nice new node in Unreal Engine 5, which is called named reroute node. So we call that sand, and now we can unplug that. And in the layer blend, we use this as input. So that's pretty neat. We can do the same for the grass. But before we do that, let's bring some color to the grass. So we can hold L and do a left click that brings us an alpha lerp. And we can use a grayscale and this green here. Let's make a copy of that and do a second green, which we in this case make a little bit brighter. And with this plugged in now into our alpha lerp, we can lerp between those two values with the grayscale. So, and when previewing this is what it looks like. So now again, we do the named reroute node, name that grass, and also color that green. So it's a little bit better for our overview. And now we can plug this into the layer. So this is a really nice way to keep your graph clean. And very often it's the small things that can make a big difference. You could also make a material function here, but we keep it like this for now. So, and here's the result on our landscape. So when we get closer, this is pretty nice and actually what we wanted. So next, let's try to populate this with some grass and some rocks. First, let's spawn some real grass. Before we start, let's change the light direction a little bit to get a nicer spot here in the middle. And then let's create a new folder we name environment. Here we want to import a static mesh from an FBX and another grayscale texture. We keep working with the defaults for now. When we open up the grass clump mesh, we can see how it looks like. So let's make this grass material very quickly. We remove the color and drag in our texture. Where the texture is black, we want to have it mask out the material. So for that, we need to change the blend mode from opaque to mask. Now we can plug in the texture to the opacity mask. When we check out the grass mesh now, it begins to look like we want. Let's bring some color back. We go back to our landscape and we steal the setup by copy pasting this in our grass material. And then we connect that with alpha and the base color. And if we take a look, this looks nice. So how do we get this grass into our level? We could use the foliage tools to paint it in, but there's an easier way. And we can leverage our landscape material for that. When we look for output grass node, we can add that. And when we select that, we can see there's a grass type we can attach here. So we need that asset. Let's create that asset we find under foliage, landscape grass type, and call that f_landscape grass. After opening it, we can add different grass types, but one is enough for us. So here we add our grass clump and then we
bump up the density and we change the min and max scale a little bit. And back in the landscape, we can add our grass type now. So next is a question where to spawn the grass. Here's where the layer blend comes in. We know already where grass was painted. By adding the sample landscape node and changing it to the layer name grass, we are actually done. So back in our level, we have now grass. Isn't that cool? So next, let's get really crazy with some rocks. We want to import an FBX named flat rock. This rock has over 6 million triangles. So now we want to change our import settings to build Nanite and then hit import. Now I will speed up this video, but I can tell you that importing and creating the data took under 3 minutes and it's around 140 megabyte big in the content folder. With this done, we can drag our rock into the level. Switching to Nanite visualization triangles, you can see Nanite in action rendering only the amount of triangles needed. If you want to learn more about this awesome technology, check out our other videos, including the one from Matt and Galen, where they show you how to convert your existing scenes using Nanite. In this material, we do not want to work with the mesh UVs. So first, let's import another texture for the rock, which is a tileable texture again, and plug this into the base color. And then let's see how that looks like on the rock. So not what we were looking for. So here we do the same as we did for the material, for the landscape, and use absolutely world position, mask that out and divide this, in this case by a very, very high number, and then plug that into the UVs. I think we do something like 1024 here, and let's see how that looks like. So much better, but when you look it from the side, that doesn't look really nice. It's really stretched. So instead of masking RMB, we using Y and Z, so to say. So when we apply now and go back, then we can see it's okay from the side, but now our top doesn't look nice. We can use a little trick here. So we are looking for the vertex normal, and here we can check again with a mask, and this time we only use B, which is Z, which is looking upwards. And then with a lerp again, we can lerp between two different textures. One is our rock, so that's from the side, and then we have to bring something else. Something else in our case can be the sand texture we already used. So we plug this in, and that will have the same issue like we had with the other texture. So we go to our landscape and we steal briefly our setup here. So we could make this now a material function when we use this in different materials, but for our little purpose, this is enough to just copy paste. And here it is, our little Nanite rock. So let's go back to the valley, and here it is. And we want to add many of them. So for that, we will use the foliage tool. Here we can add foliage assets, but we don't have one yet. So let's create one under foliage, static mesh foliage, and we will name this f_flat rock. After opening it, we can add our static mesh, and let's change some values, like for example the Z offset. We also don't want this rock aligned to the surface normal, and this rock is big, so it should have collision. So we set that to block all, and it also should influence the light. So after saving that, we can go back in the foliage tool and add it to our palette. Here we can change the density and the min and max scale. We could also override other values or do non-uniform scales, but let's keep it simple for now. Let's test how that will look like. First, we try to get a better overview of the scene, and then we select the rock to be spawned, and now we can actually begin to draw them into the scene, but that's not enough. More rocks. So let's increase the density. No, that's still not enough. So increase again. And then let's begin to paint. Yeah, that looks nice. So let's begin to cover the whole valley with rocks. So that looks nice. More rocks. Let's add just a few more rocks. So we have now a lot of Nanite Rocks with 6 million triangle count in this scene, and I think that's good. When we now change the view mode to Nanite visualization, you can see a high density of triangles, but there's no noticeable impact on my performance. So yeah, that's where we are. Let's get rid of the rock we placed at the beginning and go back to the crate by opening up the static mesh. Because there we can check Nanite and hit apply. This doesn't have much polygons, but as Nanite is a general optimization, we can profit from it. Matt goes deeper in his video about conversion from UE4 to UE5, as does Chris Murphy in his guided tour. Let's add a bit more vegetation. I'm using the assets from the nice sample project Statobot, but this time we want to migrate the trees and the fern from this project to ours. We do so by selecting the assets we want, do a right click, go to Asset Action and then Migrate. We will be presented with a list of all asset references that we want all. Now we need to choose the content folder to our target project and migrate. Here we are back and we have now a new folder with a hierarchy from our source project. This static mesh foliage we can now add in our foliage tool. For example, the fern. We want a slightly smaller scale in this level, but we keep the density. And now we can select them and easily paint them onto our landscape. Maybe some more here, just to give it a little bit more color. And we can do the same with the trees. Here as well, we want a little bit smaller trees. And as with a fern, we can just paint a bit in here and until we have some nice trees in our little valley. So now with the fern and the trees, this begins to look like a very lovely scene. But now let's switch gears and begin with the gameplay. Before we start, let's press play and see what happens. So besides our crates falling to the ground, we can find some yellow colored actors in our outliner. Many of them are default actors that get automatically spawned, like for example the game mode or the pawn or the player controller. So those three we want to replace with our own. In the project settings, under game mode, we find the default game mode base, which defines what classes are spawned. Also, the startup maps are defined here, so let's briefly change that to our valley. And now we want to make an own game mode, an own pawn, and an own player controller. So let's create a new folder and name that one Framework. In there, we want to create a new blueprint class. We worked only with an actor before, but blueprints can be made out of many different classes. When we open up an actor in our classes, you will find that our crate is a child of an actor. And a character is a child of a pawn, which means they inherit functionality from their parent. But we will based on the game mode base and name this one BP game mode for now. Next, we need a character. A character is based on a pawn and comes with built-in functionality we will use. We will name this one BP bot. So imagine this being the body that runs around in our scene, but we also need a brain. In Unreal terms, that is the controller. We will need a player controller, but we will also look into an AI controller later. We name this simple one BP player controller. Now we have to tie all the three things together and add it to our level. When we open up the game mode, you can see it looks like a normal actor blueprint. We could even have logic here the game mode should take care of. But we will only override some default classes here. First, let's add our player controller here. So instead of the default one, we want to use our BP player controller. It also spawns the default pawn class, and our BP bot is a character that's based on a pawn, so we can add that here. So let's save that and close it. Now we have to tell our game to use our own game mode. We could add it to the specifics of this level in the world settings if we would have different game modes for different maps, but here we just want to add it as a default for all maps, so we do it in the project settings. And here you can see there's a BP bot and the character now. Next, we need to define where our character should be spawned in the world. We use the player start actor. The game mode will use it automatically when it's in the scene. This blue arrow shows us the direction the character will be orientated when spawned. When we use the end key, it will be placed on the ground. So let's find a nice spot to start from. When we now hit play, we will find ourselves at that location. With this button, we can detach from the player controller to get back to the editor controls while the game is even running. And when we now look in the outliner, we can find our BP bot and other blueprints we made. So now we have our basics set up and can move to the camera. We can have the camera in many different places, like in the controller, but we will add it to the bot itself. When we open up the character and take a look in the viewport, we will find different components, like the capsule for collision and movement, or the arrow component that shows us a forward direction. And then there is a skeletal mesh component that we will use later. And the character movement component that will help us move this character around and has a lot of values we can tweak. Let's make the capsule not hiding in game so we can see it when playing. When we now press play and detach, we can see the capsule. Visibility is not great in the video, but it will serve the purpose for now. Let's stop and go back to our character blueprint. For our little game, we don't want to look through his eyes, but we want an own camera that's looking from top down. To do that, we will add a component called spring arm. That will give us some neat options. We could rotate it or scale the arm length, but before we do, let's attach a camera to the spring arm. And now, after that, when we select the spring arm again and change the rotation, we will see that the camera will follow. Then we want to move it out a bit, so we increase our arm length. Now the camera is above the character looking down. Let's select the camera and change the field of view of the camera. We do 45 degrees for now to get a little bit of an isometric look. The spring arm has some more handy features. It could check for collision to adjust the camera, but we don't want that here, so we disable that. Let's save and check out how this looks in game. Awesome, this is actually what we are looking for. So next, let's do some movement. Again, there are several ways to do that. In our case, we want to implement the input the player is giving to the player controller we made. Remember, the controller is a brain controlling our body, which is our bot. As this is our first real logic, let's briefly talk about these events. Here's a begin play and a tick event. There's actually more, for example, a destroyed event. This is basically the parts every actor goes through in his lifetime. Begin play when he's spawned, tick is updating while he's in the world, and destroyed when he's removed. But we don't need that for now. Now we use print string to display some text on screen. It's one of my most used nodes. First, let's hook it up to begin play and see what it does. So when we press play, you will see in the upper left corner printed hello. Let's do it again in case you missed it. Here it is. So let's go back, stop it here, and then hook this up to tick. So when we now hit play, you will see it's printed rapidly every tick. For that reason, you want to be thoughtful what you do here. Complex things on tick will have an impact. But we want to move our character every tick. As this is a controller and not the character itself, we need to get access to our character. The controller knows what it's controlling, so we can use the get controlled pawn. So this pin is now our pawn we can give orders to, and we will find add movement input on the character. Now we hook this up to the event, so it's get called every tick. For simplification, let's say this goes to the movement component in our bot. It needs a direction, so let's set the x of the vector to 1. Hit play and witness our actor moving in world X direction until it gets blocked. Now we need to figure out in which direction we want to go. In blueprints we have access to many things, and this includes the location in the world under the cursor. You can go deeper and have different trace channels, but we keep it for everything that's visible for now. Here is the hit result, and as it has many information, we can break this struct to see what it gives us. In our case, we only care for the location. As we now have our location in the world where the cursor is, we need one more, and that's where our bot is in the world. We can do get actor location on the pawn. With this both locations, we can use a vector mask function called get direction. It gives us a direction of vector from 2 locations. This is exactly what we need here, so the character moves in the direction where the cursor is. When we now start the game, we will see the bot will be with the camera attached following the cursor. So he's going left and right and down and up. Super cool. I didn't click in the viewport when the game was running. If I would have, you would have seen the cursor disappear. Fortunately, the player controller managed that, and we can go to the details and check show mouse cursor. So if I now start the game and click into the viewport, the mouse keeps being rendered and the character following that. As we do not want to follow the cursor all the time, we need to introduce some player input. To add input, go to the project settings, scroll down to input where we find different bindings we can make. There are axis bindings and there are action bindings. We will only work with action bindings, and you can imagine this like digital on and off switches. Let's add a binding, call that toggle movement. We can click this little icon here to press a key to bind that to our action. Here I do a left mouse click so you can see this is mapped now. Back in our player controller, we can remove the begin play for now. And now we can look for the new event we introduced with the binding. We will find toggle input here and add it to our graph. So this has two execution pins. One is fired when it's pressed and when it's released. So now we only want to follow the cursor while we hold the mouse button down. So to do that, we will add a variable here and call that add movement. This is a boolean, but there are many more variable types. In toggle input, we want to set this variable. So when it's pressed, is fired, we set this to be true. And then when we copy paste that, attach this, when it's released, we want to set this to false. And now we only want to add movement while this is true. So we get the variable, and from here we can look for an if or a branch node. With this, we can say execute this order only when the variable is true. So we are done. Let's start the game. And he is standing around, and when we press the mouse, he's moving in that direction. And he stops when we release the button. So this feels quite nice, and it's the first time we have a feeling of really controlling our little capsule here. But just moving a capsule around is kind of boring, so let's get an animated character in. Back in the character, we had the skeletal mesh component. We want to use that instead of drawing our capsule here. So to do that, let's create a new folder and call this character. And here, let's import the FBX that contains our skeletal mesh. In the import menu, you can see Unreal already identified it being a skeletal mesh and ask for a skeleton. In our case, it's the first skeletal mesh we bring in, so we want to have import mesh checked. What we don't want for now is automatically generate a physics asset. The rest, we leave it like it is, and then we hit import. When we open up our character folder now, we can see different assets that got created. We already know about the materials, but we have a skeletal mesh and a skeleton. Let's open this. The skeleton that got created from the mesh has all the hierarchy of its bones. Let's show the bones for a second. Most animation assets will need to reference one skeleton. So the second asset we have here is the skeletal mesh. You can see this as a skin, so you could have different meshes using the same skeleton. It contains data like the material slots, LOD settings, post-process animation blueprints, and more. As we don't want this robot to be gray but more colorful, let's make his materials quickly. It will not be massively different from what we have done before, but he comes with some more textures and some extra nice things for his face. First, we import all textures. It comes with a grayscale albedo, an atlas for facial expression, masks, and a normal map. We start with the albedo, and we just plug this into the base color, and then when we take a look at him, it's still gray, but a little bit more interesting. So now let's add color. We use a blend overlay node and then attach this to the base color and use the parameter here. And now let's find a nice color, like for example, a bright orange. So when we look back in our characters, this is what we got. Now let's take a look at a texture. So this one here. So in the texture editor, we can display the different informations in red, green, and blue channels. Here we save metalness in red, in green have roughness, and blue has the ambient occlusion. So back in the material, we can bring in this and connect metallic, roughness, and AO to the different pins. So after applying that to our character, this is already a nice leap forward. This like this metallic look on his arms. But they have the wrong color, so let's fix this. We can use the mask texture and again a lerp node. The green channel separates the orange parts from the metal parts. So one part is orange, and for the other we add another 3 vector node and change the color to a gray. When we hit apply and go back to our character, this is how it looks like. So some last touches by adding a normal and give him some emissive parts. First we bring in our normal map and connect that. And then we have this mask texture, and that uses the red channel for emissive parts of the mesh. So we can multiply this and plug it into the emissive output. And we multiply this with a color. For the color, we take a very, very light blue. And if we hit apply and go back to our bot, we see his main body is ready. So the only thing left is now his face. So for the face, we have one extra background texture. So let's bring that in. This time we will plug this into the emissive color. And then we will hit apply and see how that looks like on our bot. So now let's add the eyes. For that, we have an atlas here, which is mainly a texture with an alpha masking its different expression, and it's on a 4x4 grid. So to select the face we want, first we want to add this texture to our background texture. So we use an add, and we can use the alpha channel for that because that's where the information is stored. So now we can see the whole texture added to the other. But we want to control the color, so let's multiply this with the color. And then again, let's change it to a bright light blue and add and plug this into the add. Now we will use a flipbook to help us select what kind of face we want from that atlas. And we will use the UV output. So already with this default and with this node, we can see some animation and it's shown on a 2x2 face. So let's fix that. We will bring in the scalar parameter and change this to 4 because this is the amount of rows and columns we have. So we can just plug this in here and here. And now it is running through this like an animation. So if you want to animate a texture, this is a nice way, but we want to set it to a fixed value. So let's bring another parameter. And when we're changing that, we can change the face. But in our case, we will keep the standard one, very simple like this. So hit apply and then we are done and we have our character with a face which we could animate if we want. We will add him to our bot and do some movement adjustments. Here in the bot on the scheduled mesh we can add him now. So here it is, but it's a bit in a wrong location on rotation. Let's fix that. First we rotate him 90 degrees so he's facing in the forward direction of our character logic. Next, let's take a look at the capsule. That's a little bit too big for him. First, we change the radius to be a little bit smaller, and we can probably reduce the height a bit. So back in the mesh, we can change its relative Z location so it fits into the capsule. So now we have a capsule that represents him a little bit better. It all depends on your needs, but for our little games, this is okay. So when we hit play, we have the character and it's moving around. Nice. But we can see some issues. Most obviously, he's not facing in the direction he's moving towards. So back in the bot, we can select the movement component, and here we can search for rotation, where we can find orient rotation to movement. We can also increase the speed, how fast he's doing that. So with this done, we'll face in the direction he's moving to, but so does the camera. We can easily change that by going back to the spring arm, and there for the rotation we can switch from being it's set to relative what it's attached to being set to vert aligned. So when we now hit play, it is looking like we want, and this is beginning to feel like a real game. So he's following the cursor and the camera stays fixed and he follows it. Animations are missing, but before we do that, let's go back to the character movement and make some changes. For example, how fast the bot can accelerate. The next thing is we also want to increase the maximal step height and a little bit the angle he can walk on. We want to set his maximum speed to 400, and for now we will decrease the ground friction and also reduce how fast he is stopped when no input is given. And we will do all that so he is slower accelerating and not immediately stopping when no input is there. This may feel a little bit like he's on slippery underground, and we could increase the ground friction a bit, but we will keep this until we have some animations in. First, we will create a new folder naming it animations. Here we will import animations from 3 different FBX files. In the import menu, first we will select our skeleton we will already have in the project. We will also not import the mesh as we also have that. So now it's only the 3 animations we are getting, and that gives us 3 animation sequences. Let's open the idle, which opens up this editor. So here on the left are some asset details like play rate, and down here are an asset browser with animations for the skeleton. We have a walk and a run and the idle. Now we need to connect this to our game logic, and we do this by using an animation blueprint for that. The animation blueprint is also based on a skeleton, so we pick that from our bot here and we name it ABP bot. And when we open this up, you can see here's a preview. Below there's graph, functions, and variables from normal blueprint. But the main thing here is the animation graph where we play and blend our animations. And there's an event graph for the logic we will use in a second. Let's start extremely simple and just drag in our idle and connect the pose with the output pin. After hitting compile, we can see the result in this preview. Now let's add this to our BP bot. After opening his up, we can go to the skeletal mesh component. Let's go to the viewport to see what we are doing. And here we change the class to our animation blueprint. So he's playing the idle. Back in the game, he's playing the idle pose while sliding around. Instead, just playing one animation, the animation depends on the state he's in. So he's either standing still or he's moving. We will use a state machine, and then we will call that locomotion. So it spits out a pose, and that's something we connect to our output pose here. Let's go inside of the state machine. It has an entry point where it starts, and we can add a state and call this idle. And we can have another state from that idle and call that walk, run. So this is the most simple state machine. We start at the beginning idle and we can switch to the walk. And the arrow in the middle is a transition. So we also want to go back from walk to idle. So let's go inside of the idle state. Here we drop in our idle animation and connect that. So it plays the animation when he is in idle state. And when we go back, we can also go into the run and walk, and here for now just takes a walk. We can extend this later. So now when he's in that state, this is the animation he's playing. So next we need to decide when do we go from idle to walk, and that's where the transition rules comes in. Here we can say you can enter or can't enter the state, but for doing that we need some data which we will get from the event graph. Here's an update node. It's like the tick in blueprint. And here's also a try get pawn owner node that will give us that pawn. But let's first make a check if this currently has a pawn. So we try a isValid function here. And with this now we can drag out of the pawn and search for get velocity, which will give us the bot's velocity vector at that given moment. With another vector mass, vector length x and y, we can get a float that represents his ground speed. He's not jumping, so we don't care for the z direction. And this value we save in a variable we call ground speed. So when we connect this now, this gets updated, and we can test this by using our beloved sprint string node. We can plug in the float and a conversion node gets automatically added. So when we now play the game, we can see on the left side its current speed. And it's up to the maximum of 400 we set before. So back in the animation blueprint, we can delete this now. And in the transition rule, we can use this now by getting our variable in and check if this is bigger than 0. So after doing that and pressing play again, we can see he is actually going into a walk state, but if we stop walking, he's not going back to his idle. That's because he's going from idle to walk, but the transition back is always set to false. Let's fix that by getting in the ground speed again and check if this is smaller or equal a number. And we can use like something around 5 here. So now back in the game, you can see that when he begins to walk, his animation is played, and when he begins to stop, then he's going back in his idle state. We can extend this now. Let's go into the walk and run state, because at a speed of 400, the walk will not work very well. To improve that, we can use a blend space. It can be found under animations and then blend space 1D, and we base this on our skeleton. We name it BS walk run. And when we open this up, you can see an axis here below the character, and in the details up here, we can name this axis to speed. And we can also set the maximum to 400 to match our character speed we set before. And now we can drop some animations in, like the walk and the run. Depending on the input speed, it will blend between these two. But how do we know that the blending is not feed sliding? Unreal Engine 5 comes with a very cool analyst feature for that. We can choose locomotion as an access function, and the analysis needs to know the foot bones. So we can look for the bones, which would be foot left. So we put foot left and then foot right. And once we have done that, he knows where the planting is happening. So when we press analyze, he will match the animations to the right point on the axis. It might have been a little bit subtle because my initial points weren't too bad. But with this blend space now, we can drag this in and use our ground speed to drive the axis. So if we now hit play, you can see the character following the mouse and blending from an idle to a walk to a run. So in a very short time, we have our character running around in the world and reacting to our input, which is pretty cool. So as the bot is ready, we can do even more with it. Let's drag the bot into the scene and control him with an AI controller. Because of our setup, having the player controller controlling the bot, we can also have an AI controller as a brain for the body. So back in the blueprint window, we can search for AI and select the AI controller and name it BP_AI controller. When we open this up and go to the event graph, we will not add movement or use a tick, so let's delete that. There is an AI move to function in the AI controller we can use to give him some orders. So now, how and why and when do we give that order? So let's do something simple first and execute this function a few seconds after the game starts. We use a set timer by event function and we set this to like 3 seconds. Now we drag this delegate out and type custom event. And this event we call simply move. So now we connect the AI move to function, and the last thing we need is give this order to the pawn which we currently controlling. So back in our map, we select him, and in his details we find the AI controller class, which we set to our newly made BP AI controller. The last thing he needs is to move around is navigation data, where blocking is, etc. So we go to the create menu, type nav mesh, and select the nav mesh bounce volume. When you press P, you can make the nav mesh data visible and invisible. Let's now cover the whole area we want our little robot to be able to walk in, and then scale this up a bit. This should work for now. So when we press play, we can walk around and you can see him begin to run after around 3 seconds, but he's trying to reach 0, 0, 0, because that's what the destination says by default, and we will keep it like that and come to this later. All bots have the same color, and to avoid an identity crisis on our bots, let's change that. We will use the construction script of our bot for that. When we select our mesh, we will remember that our bot has 2 materials, and his body material is element 0. This material has a parameter I already renamed to color. Back in the construction script, we can grab the mesh and drag it into our graph. And from there, we add a node called create dynamic material instance. And we do this on the element 0, which is our body material. So here we can use the instance and now set a vector parameter with our color. So the parameter name we change to color and change the color to a blue. After hit compile, we can see him in blue in our scene. But now all bots in the scene would be blue. To change it per bot, we can drag the color out of here and promote it to a variable. And we name that color. And with this little eye icon here, we can expose this variable to be editable per instance. You can see this also up here. And then we change it back to our orange we had before. Now we can give this little bot his own individual color by going here in his details panel and picking something like, I don't know, something like a blue. I will settle on that for now. So we have our own controller and an AI. So let's do some more game logic. First, let's bring in some more props. So we go to our props folder, import, and then we import a wall, a door, an orb, and some meshes for a pressure plate. When we import them, they conveniently use the same materials we already created. So that's nice. We will first start with our orb here. In game elements, we will create a new blueprint based on a simple actor and call that BP orb. When we open this up, we can use the content drawer to drag and drop our meshes into the scene, which is automatically creating static mesh components. We can make this a root element, and then on the details panel, we can go to the collision and set this to overlap with pawns only. We will use this later. But first, let's see how we can spawn that into the world. So we go back to our player controller and we want to trigger an action depending on an input. So once again, we go to the project settings and there to input, and we add another action mapping. We name this one spawn orb. And we press here and hit spacebar to bind that to that action. Back in the controller, we search for spawn orb input event. And then on the release, we use a function called spawn actor from class. And the class we want to pick is a BP orb. So with a right click and split, we can access the variables of the struct. So we need a location to spawn it. We can use the same location where the bot is in the moment we hit the spacebar. So we add this to the location, hit save, and now we can walk around and spawn orbs. With orbs in the world, we want the AI now to collect them. So instead of walking to 0, 0, 0, we want the bot to go to an orb. And we can use a function to find an orb, and we call this function find orb. This function should output if it found an orb, so we do a boolean which we call success, and we add a second one and change the type to an actor, which we will name orb actor. So let's make the logic for that. First, we want to get all actors of class. And here we want to look for our BP orbs in the scene. This gives us an area of all orbs. It's basically a list. We can use get length of that list to check if something is in it. So if this area is bigger than 0, we can use a branch. And if this is true, we found something. And if it's false, we say we were not successful. And if it's true, we found orbs. So now we make this simple and just get the first orb in that list and plug that into our return node. And when we hit compile and go back to our event graph, we can track in our function. So we made our own node we could now hook up like we did before, but in this case we can make this functional pure, and when we drag this in now it doesn't have execution pins. Be aware that also means each time a value is needed from this node it will be executed, but that's okay for here. So if we are successful we will do the AI move to command, and we will use the orb actor output and plug that into the target actor. And then when the AI reaches the destination successfully we want to move again. In addition, we want to change our timer and check that this is looping, so it's checking every 3 seconds. When playing now, we can spawn orbs, and our little blue robot will go and run to the orb. But as the orb still will be the first in the list, he will not move to another. For that, we need to remove it from the world. To do that, we can use events the components can give us. For example, the begin overlap event. We already know this actor will only overlap with pawns because that's what we said in the details. That includes our own bot and the AI bot. Here we get the actor that begin to overlap with this orb. We don't want our player to directly remove it after it got spawned, so we have to differentiate between them. So we cast to a pawn. Carefully with casting, it has hard references, and it means when an actor gets loaded in memory, everything it's casted to will also be loaded. Now we drag out the pawn and we can ask if this is player controlled. As we have an AI and a player controller, this will give us a desired result. So if the bot is not player controlled, we will destroy and thus remove it from the world. Here we are. So now let's hit play and see what it does. We can spawn orbs, and the AI now begins to follow us and collecting those orbs. So here we have it, running around, spawning orbs and having a little AI following us. Now let's add some more interaction and do some more game elements. We will do a pressure plate that will open a door, and we want our robot to be able to trigger it. First we create another blueprint actor and name this one BP pressure plate. And when this is done and we open it up, we can drop in our frame and platform mesh and then make the frame our root. What we want to do is move the platform up and down when something stands on it. To do that, we will add a box collision component that will serve us as our trigger. So let's scale this up a bit so it covers the area we want. And now we want to add a begin overlap event like we did before with the orb, but this time we also want the end overlap event. And we now want to test if this is working. So we use our print string again. We keep the hello for the begin overlap, and we add another one for the end overlap where we say goodbye. So with this done, let's go back in our level and get into the content drawer and just look for our elements, bring in the pressure plate. And when we press play and move around, you can see the hello and bye being triggered when we begin and end overlap. So this is already working quite nicely. But we don't want to output some text, but move the platform mesh up and down. So back in our pressure plate, we will first remove this print string node. And to do the animation of the pressure plate, we will use a timeline. And we name this plate animation. So when we double click, we can add different tracks to this one. But first we want to go pretty fast, so we set the length of this timeline to be ½ second. And next we will add a float track. So this track we will use to animate the plate movement. Now we can add some keys. So the first key is at 0 second and the value to be 0. And then we do another key, and that one will be set to 1 after ½ second. And with these buttons, we can focus on that area. So this value will increase over time from 0 to 1, and we will use this to move our plate. So here is our float pin that will give us a value when the timeline is playing. We will take the platform mesh in here and look for set relative location. By start, this is 0, 0, 0. We want to have this updated when the timeline plays. As we only want to change the Z value of this vector, we will use one of the mask nodes and search for multiply. The pins here are grayed out because it's wildcard pins that can become different variables. They get automatically changed when I track something in. And now we can split our location vector and connect the output to the Z component. So when the platform reaches 1, we want the plate to be at around -20. So let's hook this up in the timeline, and we can do it play and reverse when end overlay with plate. So now back in our level, we can run around, and you can see it's already triggered, but maybe a little bit hefty. So before we continue, let's stop here, go back and fix this. The value is a little bit high, so we go to -10, and I think that should work better. So let's play again and see how that is doing. Yeah, that's what we want. So the plate is moving down and up. So we have the pressure plate. Now let's create another actor for our door and call this one BP door. When we open this up, we do the same as before. We will go to our props folder, and first we will bring in the wall frame and make this one the root. Next, we need the two door meshes. It's the same mesh for both, so we will add 2 of them. And let's name one door L for left and the other one door right. As we want them to move around here, but it would be easier if the relative location would stay at 0, 0, 0. So let's do a small trick. We will add a scene component, and we call this like anchor_L. And we move that to the proper position. Then put the door under that anchor and bring back the relative location to 0. We do the same for the other side. So we add another scene component and call this one anchor_R. And then move this to its proper position on the other side. In this case, the door moves in the opposite direction as the other, so we rotate this one 180 degrees. And now we can put our door under the anchor, and we have a setup we can easily work with. Back in our event graph, let's first delete those nodes, because this time we will start with custom events. The first one we want to do is calling this one open door, and then we need a second one we will call closed door. And again, we will do a timeline calling this door animation. This is nearly the same setup as before. We will do one tiny thing different, which you will see in a second. So door animation, and then this time we will make this also as short 0.5 seconds. We could also do vector tracks here, but I personally prefer to work here in a 0 to 1 space and tweak the values afterwards with a multiplayer without the need of changing the curve every time. So the curve we want to model just like how in this case the animation is played. But first we need this first 2 keys. And then we can do it a little bit more interesting by selecting those keys and changing them from linear to break. And that gives us tangents. And this tangents here we can use to manipulate the curve. So we can bring this down to have a more interesting sliding. And back in the graph, we can take both door components and again look for set relative transform. We put this under the anchor, so that will help us a lot. Again, we split the vector, and this time we use a multiply again, and we will multiply it with -70. We connect it to the Y component, so the door slides in and out of the frame. So open door should play time forward, and close should play it in reverse. So this is it, and for a quick test, we want to see if this works, so we will get back our begin play. We want to open the door after a few seconds. I normally prefer the set time setup, but we will use a delay node, which will work for now. And then we will open the door. So we can go back to our level, look at our BP door, and drag that into our level. Let's try to find a nice spot, like here at the entry or exit of the valley. So we have to try to open that. We could properly place it a little bit nicer, but I think this works for now. So et voila, after 3 seconds, the door will swing open. So how does the plate now tell the door when to open? There's a lot of ways to do it, and you can look into Blueprint communication to learn more. I want to show you one way, and that is using an own component. We can create a blueprint here, and we find an actor component. Let's create one, and let's call this one BP interaction component. Imagine this to be a small container for game logic you can add to any actor in your project. So when we open this up, it looks like any actor blueprint we have seen before, but it doesn't have a viewport or components. Let's remove this for a second. We will do something extremely simple here. We create a custom event that we can call from outside later. First, we call start interaction, and then we do a second one, and this one we will call stop interaction. Next, we will use an event dispatcher, which will give us a possibility to shout out into the world that this event occurred, and we call this one on interaction. And up right here, we can add a variable, and we keep it a bool and say simply on. Now we can drag it in and call this one from start interaction and say this is on, and then we do a second one on stop interaction, and here we say it's false. That's all our component will need. So let's hook this up. In the pressure plate, we can now add our new component we just made. There it is. So let's move the overlap events a little bit to the side. And then we can drag in our component and use it as any other. From here, we can call the events we created. Start interact, on begin interact, and then start the animation. And also stop interaction when the end overlap is called, and then play the animation in reverse. To show this is already working, we go back and use our print string again and saying, for example, on when the interaction starts, and we do another one and we just say off when this happens. So with this hooked up, we can test if this is working. So let's start our game and move our character around. So when we enter the plate, you see on and off. So this is already working quite nicely. Now the door needs to react on that. Back in our door, we can remove our test code for opening the door. And at begin play, we want to listen to the event dispatcher of the component that's calling out into the world that an interaction started or stopped. First, we will add a new variable type and call that trigger. Then we change the type from a Boolean to an actor object reference, because any actor could actually have our interaction component. We can drag this variable in, and then we can check if this is even existing. So we do a right click and change this to a validate get. And now from that trigger, we can move this pin out and search for get component by class on that actor. So here we can check if this actor has a BP interaction component. So again, we check if this is valid. And when both is the case, we know we have an actor here that has our game logic we just created. We can drag out here and assign a custom event to this event dispatcher we called onInteract. So at begin play, we assign this event to the event dispatcher, and when this is calling out, we can react on that. We can now use a branch again to decide what to do when this is true or false. So if it's true, we want to open the door, and when it's false, we want to close the door. And with this, we are done. So let's save and go back into our level and set the trigger variable by selecting the door. And I forgot something. So we have to go back to the door and make the trigger editable per instance with this eye icon. So let's compile and go back. And when we select the door now, we can use a picker to select the pressure plate. When we now start the game, we can walk onto the plate, and that triggers the door. And it leaves the door and open and close. And it also means when we now spawn our orbs and our little bot collecting them, we can make him open the door for us so we can safely leave the valley. Woo! Even after so many years, I still love the moment when all these little features come together. Oh, by the way, we also can push the crate onto the pressure plate because we didn't check who's overlapping with it. Let's do a bonus round and add a bit of polish by adding effects, sounds, and a bit of camera shake. We will start with a dust effect for the bot's running animation, and first let's make a folder and call that effects. Here we create a completely empty Niagara system, and we will call this one FX Dust. So let's open the Niagara editor. Again, we have in the middle a big graph. Here are some parameters, and here is a preview. We will do something extremely simple. First, we want the system not to loop, but only play once. Next, we need an emitter. We could use one of the many templates, but we'll start an empty one. This also has life cycles like an actor, but in update, we add a burst, a spawn burst. And let's add something like 10 particles. In particle spawn, we can set some particle values. First, we set the color to do something that could look like sand. Next, we want a bit of randomization for the size of the particle. So let's check uniform, random uniform, and do something between 2 and 4. We also want to randomize the mass a bit for the gravity we will introduce in a second. And next, we want to add some velocity when the particle gets spawned. Adding this also needs a solve forces module, which will be added when we hit fix. Instead of a linear force of all particles, we want to switch to a cone, and the direction of the cone we want to set to -1 to fit our character later. So in preview, you can see now 10 yellow particles moving in -x. We could change the velocity speed, but we will keep it for now. There are many more things we can do with our particles, but we will keep it simple. As this should be dust, we want to scale it up over time. So in particle update, we will look for something called scale sprite size. This gives us a curve, and we want it to be much bigger, like maybe something like 15 when it's the end of his lifetime. So you can see now they are getting much bigger. Now they should move a little bit more interesting, so we can add a curl noise to get a little bit of chaos. We can increase the strength a bit, which gives us this. So next, we could also change the frequency, but we will keep it for now. Next, let's add some gravity. So if we add gravity as a force, they will by default fall down with -980. We do not even want a negative value. So like this, in our case, we want to get it a positive value. So that's much better. Maybe this is a little bit much. So like that. Here is where also the masks come in that we set earlier. Last thing is changing the alpha over time so it blends out. We can use the scale color, and we can change this from a fixed number to a float from curve. Now we can track the 0 value to happen a little bit earlier in the time, and we have particles that begin to blend out. Niagara is very powerful, and I'm using only a super tiny piece here, but we need to move on and see how we can use a dust now. To spawn that on the footsteps, we will go to our animation and open the run animation. Let's change the camera angle and stop here. Below of the camera, we have different tracks, and one of them is called Notify. We can scrub to where the right foot is touching the ground, where it's planted, like here, for example. Right click and add Notify is where we find Play Niagara Particle Effect. When we select this, we can add our dust effect in the details. And when we now moving on the timeline, we can see it gets spawned and played once. But it's spawned at 000 of the character and not where the foot is. We can add a bone or a socket name here, and we will pick foot R for this right foot. Now it gets spawned where the foot bones are. Let's do it for the other leg as well. We will add a Notify. First we will scrap where it is, so here, and then we will do right click and add a Notify. Select the event, and we switch this to foot left. Now we have them spawning at the right location at the right time. When we now go back in our level and hit play, we can see the particles getting spawned when he's running around. So we are leaving a little trail of dust behind us. Audio can help greatly with player feedback and is as important to a game as all other aspects. Let's make some procedural generated footsteps. We will add a new folder and call this audio. For this one, we will use Meta Sounds, which is a plugin you might have to enable under plugins and restart your engine, which I already did here. So we will add a new Meta Sound source asset, which we will find under source, and call this one SFX footstep. When we open this up, you will see a big graph again. We can compare this with a material editor where you can play pre-made sounds, music, mix it, or even generate sounds out of thin air. Which I do here with a white noise. Wow, that was loud. Let's control this noise by adding an envelope. There are several ones, but we want the one that outputs audio. We multiply this result now with our noise, and then we connect this to the output. We also connect the on done pin to the on finished, so the sound knows when it's ended. Let's hear how that sounds like. We can hear a difference as this sound is now blending in and out. Let's modify the attack timer and the curves and test again. That's close. So we can extend this now by adding a square generator. Here we set the frequency very low and now add this to our noise with an add node. And then we will plug this into the multiply with our envelope, and that's what we got. So we increase the pulse width a little bit and the noise is very loud. So we multiply this with a float like something 0.1 and then plug that in. And this is the result. I'm obviously not a sound expert, but I hope you can get an idea how powerful this is. So it's close enough for me. Back in our run animation, we can add a new notify track. So let's stop this for a second. Now we can do a right click, add notify, and then play sound. When we select this, you will see that our footstep is already selected. That's because I still had it selected in the content drawer. So, and this is how it sounds like. So let's add a second notify with the other feed, place it properly. And this is our animation. When we play in game, we can see and hear the bot running around. And when we spawn some orbs, as we use the same body, you can now hear both bots running around, making noises. Isn't that lovely? As a last touch for this project, let's shake the camera a bit. We go to the effects folder and there we create a new blueprint class. This time we look under all classes for camera shake base. We will add this and call our ones just simply camera shake. When we open this up, we have some properties we can change. First, we pick Perlin noise. And then we will tweak the amplitude and frequency in a second, but let's open timing first. We reduce the duration to something very short. And we also decrease the time to blend in and out of the shake. So for example, something tiny like 001 and 005. For the location amplitude, we do an 8 and the frequency we do 12 for now. Let's save that. I want to play it on the door, so when the door opens or closes, we want the earth to be shaking. After selecting the door, I press Ctrl B to find the asset in the drawer. In the event graph here, where the door gets moved by the timeline, we can add Play World Camera Shake. We select our shake and we need to define where the location of the epicenter is. So to do that, we want to do it where the door is, so we do get actor location and then plug that into the epicenter. We can specify the radius, this is a Feldby, and we increase this to a very high number. And hit save, and let's see how that looks like. When we now run around and trigger the door, the camera shakes. A pretty heavy door we have here. And that's it. We made a tiny game touching a lot of different new and established features in Unreal Engine 5. We imported a static mesh and textures, we made different materials, we used high polygon rocks, created a character, set up his animation, added an AI, and did some game logic, spawning and collecting orbs and adding an interaction component to trigger a door. We made some dust, we generated sound, and I can imagine this is a very good start for a small puzzle game. We used assets from our own StegoBot sample you can download on the marketplace. A lot you learned here can also be found in that project. It's a great place to start if you prefer learning by tinkering. If this isn't enough for you, I recommend you check out our new starter game, Lyra.
We hope this will help you getting started and looking forward to see what you will create in Unreal Engine 5. Join our new developer community and don't miss the great videos my colleagues and some of the community members already created. Thanks for watching.